let's consider the first one, the periodic table and the periodical rules. We've already passed that one, and the bounding, chemical bounding, this is the second one. We've already passed that. And then the third one, so electrolytes and non-electrolytes. We've already learned, we missed that, and dissociation of the acids, bases, and the salts. We've already passed this. So, and their sealing is slightly electrolytic. You know, weak and strong electrolytes. We will enter the constant of the dissociation. You already learned this. And ionization reactions, you know this. The hydrolysis of the salts, you know this. But we haven't learned that because this is a theoretical, and we will come to this topic, but step by step we are going to organize. Till the end of the COVID-19 lockdown, you will have learned all of this 37 topics. If God blessed us, and if your efforts is enough. So, and the physical and the chemical properties of the carbon. You haven't learned it. And this is also, this one. And we're learning this 19, the electrolysis and its practical importance. So, what else? That one and that one. After we finish the practical topics, we will gonna learn the theoretical, which means you will think mostly about the theory, not the mathematical calculation, okay? Because these topics are more about the theory. They are not about the mathematical calculations and using formulas, most of them. And you can see here the translations of these topics. Metal secondary, subgroups of the secondary. If you learn the periodic table perfectly, and its properties, you can surpass several topics of this list. You can automatically surpass because several of these topics are super relevant to the periodic table. Okay, and this is also the theory, and this is producing steel. It is also the theory. You know, why do we need the producing steel? I'm just kind of hesitating. It is out of topic. You are the people of medical school, right?
Yes, but the books are the term standard books, so we don't change the books. I think these are the topics of the book of 9th grade.
Yes, they want to give you the general knowledge from everywhere. Yes.
Yeah, so our school system is like till 2 o'clock we do the normal books, and after that we have extra classes which include like extra biology, extra chemistry, extra maths, physics, and etc. and all.
Yeah.
After 2 we have extra knowledge, but till 2 we do the the RAM standard books system.
Is your school specialized?
Yeah, to biology and chemistry.
Biology and chemistry. Yeah. So in that case,
So it
the school
opened
system.
last year.
Yes.
It opened last year, and my knowledge for chemistry was like total zero. Now after your explanation and all, I can understand much better.
Okay. So if you understand the chemistry very well, um, but so the basic chemistry is some kind of hard to understand, and inorganic chemistry is also hard. But organic chemistry, it is more systematic. Systematic. In organic chemistry, the millions of the chemical substances can be bound to a single formula, and their properties also can be uh, categorized into several concepts. So I consider that the problems of the basic chemistry is more important.
Which chemistry are we learning?
Yes, this is a basic chemistry.
The ones that you're teaching me?
Yeah, yeah. This is a basic chemistry, yes. And we haven't, so some kind of, we're learning also the parts of the inorganic chemistry, because the inorganic chemistry is more about the uh, oxides and bases, acids, which are not containing the carbon included substances, carbon atoms. Silicate industry, so the silicate industry is the inorganic chemistry is more about. The basic chemistry is more about the general rules which can apply to any branch of the chemistry. For example, if you uh, if you get higher degrees, for example, bachelor's and master's degree, and you will see how broad the chemistry is. We have so many branches of the chemistry: medical chemistry, analytical chemistry, physical chemistry, and also uh, we have the combination of these uh, chemistries, also biomedical chemistry, biophysical chemistry, colloid chemistry, a lot of chemistry. But the basic chemistry which we are learning right now can be applicable to any of these branches. Any of these branches. These are basic rules. You right now you are building the foundation for your future learning. That's why you should make your foundation concrete and strong. So, so overall we have 37 topics. Now we've learned how many topics? 7,
8.
8. Yeah. Where is it? 8.
19,
8.
19.
9. Okay, 9. Um,
9.
but before we've learned
No,
also some out of topic themes. Yes, and the beginnings. I remember that. But uh, if you learned, if you finish all of the practical topics, theory becomes the easy. because the only thing that you have to do is to read and analyze the information. It's not about the calculating or mathematics. You just have to make research, making some kind of gain some kind of essential information, which is current topic in the chemistry about this. For example, the most important carbon compounds. What are they? So, what are the most important carbon compounds have you learned right now? Can you tell me? For example, this one. What is it? And this one. Both of them contains the carbon.
Methane, and the second one,
What is it?
I can't. The second one, I don't know. The first one that you wrote is methane.
Yeah, this one is what? This one. And also you have to recognize this one.
Acetate.
Acetate. The most essential carbon containing compounds. I don't remember the exact English name of this because I forget it, but I know the Uzbek name, the mochivina. Um, so ulcer, no, it's not ulcer. Methane, acetylene, and the acetate. You have to also know this one, the ulcer. No, it's not the ulcer, it is some kind of name. I don't remember right now. And you know what alloys is? Alloys,
No, that's I wanted to ask you what that was.
it is a mixture of metals. Mixture of metals. For example, iron melted in the copper. This is a mixture. You know the brass. Brass contains lead and copper. Yeah. Mm. Brass is
What did you say?
brass. You know. So brass. It's kind of
Double S.
yeah the brass yeah double S. But do you know that that alloy? Have you heard about that alloy? Brass.
Yes.
Yeah.
Yes.
It is a mixture of the copper and lead, if I'm not mistaken. Lead.
Is that always like that, or does that change?
Yeah, the portions can be changed also. And you know the steel. Steel. This is also the alloy. It contains carbon and other metals. Other metal. It may be different metals between the iron and the carbon. It is a mixture of the metals. Is that clear?
Yes.
So let's go to our topic. I'm gonna open the Telegram and we will check together your problems. So first of all, just the first, define oxidation reduction in terms of electron transfer and change in oxidation number. Can you define them orally? Uh,
Did
you should
you?
you should have automatic knowledge. Whenever you heard that
Oh,
name,
I didn't see your screen. I didn't hear it. I missed it.
you didn't see my screen.
Yeah, the screen came after you spoke, so I didn't hear. It was like my concentration was gone.
Uh,
So oxidation is the loss of electrons, and the oxidation number will be high. Reduction is the gain of electrons, and the oxidation number will be low.
yes, right. And so, what should we do in order to equate the number of the electrons during the redox reaction?
I'm not sure with this one. So I wrote the answer, but I'm not sure.
So you have, in order to make the equal number of the electrons, you have to exchange coefficients. Yes, the number of the electrons
Is this the second question?
the electrical process involves redox reaction. No, it's not the
Did
second.
you read the second question? Which question did you read?
I'm asking you define oxidation reduction in terms of electron transfer and change in the oxidation number. But this question is
Okay.
not here. I'm just uh, going deeply in detail, you know? So, electron transfers from one atom to another, and
Yes.
it means the number of the electrons which are being transferred should remain unchanged. Yeah, but as you can see, the
Do, do they transform from reducing agents to oxidizing agents?
um, from so
Yeah, like there are two substances. Do the electrons transfer from reducing agents to oxidizing agents?
yeah, so oxidizing agents, yes, oxidizing agents attracts the electrons, and reducing agents should uh, lose. They should lose the electrons. Is that clear?
Hmm.
So, why must an electrochemical process involve a redox reaction? Can you explain?
Redox, re- so redox reactions take place when electrons are transferred from one substance to another. And in an electrochemical process, electrons in the same way flow from one substance to another, which is driven by redox.
Is that it? Can it be reason why the electrochemical process? must involve in redox reaction? Can it be the reason?
See, so they transfer from a substance that is oxidized to one that is being reduced.
Yes, this is the process itself. But why it should be the redox reaction? Why it's not the neutralized reaction or as a kind of um, exchange reactions or the substitution reaction? Why? In the chemistry we have so many reactions. We have so many reactions. But why exactly the electrochemical process should involve the redox reaction? Can you tell me?
Why?
You're just approaching the answer, but you haven't arrived. Because, as you can see before we do, um, as I mentioned before, um, during the electron transport, electricity forms. That electricity can be used for devices. As I as we can see before, the batteries, cell phone batteries, you know, that's why because of the electricity that comes from redox reaction makes that reactions the main reason why the electrochemical process should be
So the answer
involved.
is during an electron transfer,
Electricity
your voice
can,
is breaking.
during the electron transfer, the electricity, I mean the current of electrons can form, which means these reactions,
Your voice is breaking a lot.
can you hear me?
Yes.
Okay, I'm saying again, during the electron transfer, the electricity can form, which means the chemical energy turns into the electrical energy. That's it. Chemical energy turns into the electrical energy.
So during an electron transfer, electricity forms. That electricity is chemical energy. That
No,
chemical energy will form into electrical energy.
yes, chemical energy can form the electrical energy. Yes,
We get chemical energy from the electron transfer.
yes, by using the electron transfer, because electrons are moving towards the same direction, which means the electricity is forming. Is that clear?
Okay. Yes.
So next question, can one half reaction and redox process take place independently of the other? Explain. Is that possible? Only one half reaction can
Well, can one
take
half
place.
reaction and redox process take place? Half reaction and redox takes place? No. Processes will take place until and unless they're connected.
Yes, right.
Because
One,
redox requires both of them to work simultaneously.
yes, right. We can't imagine them incorporately and divided. Okay. So Let's go to the next. Water is used to balance the oxygen atoms in the half reaction method. Why can't this one, ions, be used instead? Can you explain me?
Well, I thought that, I mean, my point of view was water, I mean, yeah, water is a neutral molecule, whereas O to the power of 2, what, how do we call this?
This is
O to the
a
power of 2
oxygen
minus.
ion. Oxygen, yes,
Yeah.
oxygen ion.
Whereas oxygen ion is negatively charged. While balancing, we balance both atoms and charges. So when the oxygen ion, if we use the oxygen ion, then only the atoms will be balanced.
Yes, right, right. For example, let's consider mm, this one. The first thing that we have to do is to balance the atoms. As you can see here, one manganese and one manganese here, but we have to balance the oxygens. That's why we have to add the water 4 molecules. No,
We lied it here, yeah.
here we have to add, and as you can see, we adding water. Why? Because these ions can form in the aqueous solutions. Aqueous solution. In the aqueous solutions, water molecules are very multiple. That's why we use the water molecules. And when it comes to this, in the in this environment and in the solution, you don't have such kind of ions. You know, it is not a real ion. You don't have it in this solution. It doesn't form in the solution. You don't have such kind of ions. The first reason, the non-existence of this ion in the solution. The second reason, here, if this molecule have the extra charge, the balancing can be destroyed. This is the second reason. Did you get it?
The first one is the non-existence. I didn't get the
Yes.
second one.
Yeah, because non-existence in the solutions.
And the second one?
The second one is if it has a charge, the balance is not the proper way. This balancing is not the proper way because you're impacting to the overall charge of the equation. For example, here. So if you add if you add O2, if you add the hydrogen to, oh no, this one, minus 2 times here. And the sum of the charges of this equation automatically changes after you've added these ions on this equation. For example, on the original position, this equation totally have 2 plus charge sum. Yeah. And after you've added 2 ions of the oxygen, it means 2 multiply minus 2. Yeah. And it's equal to minus 2. You see the change. You're breaking the mathematical rule doing such kind of actions. 2 equal 2. Yeah. And you you subtracting by 4 on the left side, and you not adding extra minus 4 on the right side. That's why you breaking the mathematical rule. Okay, is that clear?
Yes.
Let's go to the next. During the redox balancing process, what step is taken to ensure that electron loss equals electron gain?
I didn't write the answer for this one.
So this is more about the equating the electron numbers. For example, you already show this one 2 plus water, and this one equal to manganate O2 hydrogen, so 4. Okay, and let's write the second reaction. For example, SO3 2 minus goes to SO4 2 minus. Okay, and you're gonna add here 1 water, and it's equal to this. No, it's incorrect. I should find another one. So 2 plus, let it be, and this is it, 4 plus. And in order to make equal the charge sum, you have to add here 2 electrons. 2 electrons, yeah. You have to also add here 2 electrons. As you can see here, the given and taken electrons are equal each other. It shouldn't be equal. So here minus 2 minus 4 would be. And we have to add 2 electrons here. If it is minus 6 minus, and we have to add 4 electrons. 2 4. And this step you have to do is the answer for this question. You have to balance the given taken electron numbers. So first you're gonna subtract and then exchange the coefficients. You have to multiply 2 here for this equation, and you have to multiply 1 to this equation. Is that okay? Did you get
Yeah,
it?
is there a written version? No, I know this, but is there a written version for this?
Written
Like
version?
explaining this process?
Yes, we have a written version.
No, I mean explanation of this process.
It's, we have the explanation of this process. Didn't you remember? You know,
Could you remind?
balancing, we have a title on our PPT uh, like this, the balancing half reactions
Yeah, half reaction method. By using half reaction method.
by using the half reaction method. Can you remember
Yes,
this?
I know.
And
Yes, yes,
there are instructions given, and you have
yes,
to,
I
yes,
remember.
explain this way, explain this process, how you can uh, balance the loss gain electrons.
No, but it's talking about one step which is taken to ensure. It's not talking about all the steps. It's talking about balancing process. What step? It's not
So,
saying what steps.
okay, let's um, stepwise method. Let's take the stepwise method. The first thing that you have to do is to find
R-
the
My,
skeleton
yeah, to do
of
the
the
skeleton
electron.
reaction,
Yes, this is the first step.
and and
After,
then
and then you have to do what?
you should, like, for example, if it's your manganese, if this is the thing, it will be this and this.
It means you have to
Kind
make,
of match it.
yeah, it means you have to make the number of atoms and the electron charge equal. This is the second step. Atoms and electron charge should be equal on both sides of the each half reaction. Okay, like I did now. I first add the water molecules in order to equal the number of the oxygens, and I added the hydrogen cations on the right side, and then I will add the electrons in order to make the uh, electron charges are equal on both sides. This is the second step. Yeah, I will do this for the second half reaction also. This is also included in the second step. So the third step is this one, ensuring loss electrons should be gained equal to the gained electrons. This is the third step. What about the fourth step? The
We should
fourth,
the canceling.
yes, you should cancel and add them. Add these two half reactions each other. This is the
And
fourth.
the fifth one is make the final one.
Yes. The first one and the last one is to find the pairs of these ions. Okay, did you get it?
Yes.
You can divide them into steps. So let's continue. Can you read the
Can wait a minute.
next one?
1 minute. Okay. How are protons removed when balancing a redox reaction in basic solution? We like if it's to remove hydrogen cations, we should add hydroxyl ions to both the sides to neutralize the hydrogen cations, and by neutralizing the hydrogen cation, we will form water molecules.
Exactly. Yes. Super answer. Good. After you've neutralized that hydrogen cations, you get the water molecules, and by adding the two half reactions, you will see the extra water molecules on the both sides, and you may reduce them. This is the exact answer. Next one.
Are spectator ions used to balance the half reactions of a redox reaction? At what stage might spectator ions enter the balancing process? So spectator ions are removed from the equations. So after they are divided into two half reactions. So they're found before and after the reaction. So basically at the final stage, when they combine, when the two half reactions combine, in that stage we can
So,
find.
first of all, what is this spectator ion? For example, I'm going to give you an equation.
The ones which are not included in the skeleton. Like here it will be potassium ion, because we're gonna sodium,
So that's one. So two.
so basically we'll dissociate them into ions, and after dissociating, the spectator ions will be potassium, sodium. Yeah,
This is
they will be the spectator ions.
yeah. And in order to find the skeleton reaction, we have to remove the spectator ions.
Yes,
The spectator ion, this one,
potassium, sodium.
this one.
Yeah, two sodium,
And we
three
use
sodiums.
this hydroxyl groups for,
No,
uh,
no, that's going to be there.
yeah,
Um,
this one,
yeah.
and we don't need also. Maybe we don't need.
No, no, we don't know, because then anyway the amount of water will be shown when we'll equate them.
Yes. So, and as you can see here, we form the skeleton reaction. This one is what is the charge of this? One. This is a one. This is it two. So, but We use spectator ions. We use hydroxyl groups, hydroxyl groups for some purpose in order to neutralize uh, hydrogen cations. We use this one. Is that clear?
Mm-hmm.
We use when we're adding this half reactions each other, we use hydroxyl spectator ions which are exist in the solution. So it at what stage might spectator ions enter the balancing process? So
Final.
I think the third, um, the first one is a skeleton reaction with the atoms and the electron charge.
Well, yeah, before and after the reaction.
So I think the second step we will add. At the second step, the spectator ions might enter the balancing process because, oh no. So this is a basic solution, yeah? It means after we add, we will get the total reaction. And to that total reaction, in order to that total reaction, we have to add the hydroxyl groups in order to neutralize the hydrogen cations. Yes,
Yes.
right. It means this is a third step, right? And what about this first one? Are the ions useful to balance the half reactions of redox reactions? Yeah, yes, use it. Yeah, use it.
What?
The spectator ions are used to balance the half reactions of a redox reaction. Yes, they use it.
They're not used in balancing, they're used in making the skeleton. They don't take part in the whole process.
Yes, I know, I get you. But here the problem is asking you balancing, not the finding skeleton reaction.
I know, and I'm saying they they take part in finding the skeleton reaction, not balancing.
They took part. No, they didn't take part in finding skeleton reactions.
Yes, that's what I'm saying.
Yes,
They do not take part, but they're found um,
but we
in the
use.
final stage.
Yeah.
In the final stage and in basic solutions, they might come in the third stage. No, they come in the third stage in the basic solutions. It's hydroxyl.
Yes. It means
Yes.
we use them. They are not used means we don't use them anymore. We don't need it. Do you see the
We do
difference?
use them, but not in all types of solutions.
Here you can see to balance the half reactions of a redox reaction. Yes, in order to balance this half reaction, I will add, for example, water, and in order to cover these hydrogen atoms, I will add the, for example, the hydrogen cations which are exist in the solution, which is our spectator ions regarding their acidic solution. Is that clear?
Okay. Yes.
So we use spectator ions, and we use them mostly two and the third steps. At the third step, they are used for the basic solutions. At the second step, they are used for the acidic solutions. You should conclude in this way. So let's continue. Which one? What type of electrochemical cell
Which
has
type of electrochemical cell has which type shows an okay. So voltaic cells have what I forgot the name.
voltaic cells, right? Because in the voltaic cells,
No, no. What was this G?
G means the difference between the electrical potentials.
Ah,
Half
so the
half cell
difference between the electrical potential will be less than 0 in voltaic cells. So electrolytic cells will have a higher. So they're a non-spontaneous reaction, and they have higher, and they'll show an increase. Hence, they will show an increase.
So
So
your
the first question's answer is voltaic cell. The second question's answer is electrolytic cell.
which type shows an increase in the free energy?
Electrolytic cell.
Electrolysis?
Because there are no electrolytic cell.
No, electrolytic cell means general.
Yeah, so they're going to be they have a non-spontaneous reaction, and the difference between the electrical potentials will be higher than 0. That'll show an increase. Could I explain?
So you didn't understand the second question. The second question is asking you the option between the first half cell, which is the voltaic cell, or the second half cell. Second type of
What?
the electrical cell. You know, we have two kinds of electrical cells: voltaic cells and
An electrolytic cell.
electrical cells.
Yes.
So
So I'm saying that which type of electrical chemical has less than 0? Voltaic cell. Which type of electrochemical cell has an increase in free energy? Electrolytic cell.
mm, okay. So which one do we use for electrolysis? First question.
Both.
For what?
Both.
Voltaic? I didn't hear you. Which one should we use for electrochemistry? I mean the electrolysis. Voltaic cell or electrochemical cell? Hi, can you hear me?
Voltaic.
Voltaic. Why?
Yeah, can you give me a minute?
Just can you, first of all, can you find the definition of these two cells? Can you find? Can you tell me?
I wasn't here. What did you say?
So,
I told you
can
to
you
give me a minute.
can you define these two cells?
Voltaic cell is a it's a non-spontaneous reaction, right?
So you know what you say. We use voltaic cells in electrochemistry. Why?
Because it has a spontaneous reaction, higher energy reactants and lower energy products,
Yeah, it
and
means this
they
this one this one should be
and the system works on the surroundings. It does work on the surroundings.
Yes, it's the voltaic cell can work for the surrounding.
What else?
What I mean by this, you know the definition of the voltaic cell. For example, these are the electrodes of the cell, yeah, and each one has its own potential. This is the electrical potential one and the electrical potential two. So, so in this plus sign is more, and this one minus sign is more. Okay. So in order to conduct electrolysis, this one should transfer to this, and this is a negative electrical potential, and this is a positive electrical potential. And whenever you subtract these ones, in order to find the difference between this electrical potential, in order to find the um, difference, you have to subtract them, and then it should be bigger than zero. Is that clear? It should be
Okay,
bigger
so
bigger than zero. That's why they are called the uh, voltaic cells,
no, they're less than zero.
right? Can you
In
give me?
voltaic cell, but that wasn't a definition. The one that you made me write.
So
There's spontaneous reaction, and the difference between the cell potentials will be less than zero.
is that less than zero?
In voltaic cell,
Uh, okay, if it is less than zero, it means the number of the electrons are many, and you don't need electricity, right? Did you get what you said? You know, so what about the second one? It should be less than zero or bigger than zero. Can you tell me
which one?
the second one, for example?
The one that will show an increase.
No,
That's
sorry.
going.
Electrical cell. Can you differentiate that one?
Do you mean electrolytic cell and voltaic cell?
You said the definition of the electrical cell and no, the voltaic cell. And can you tell me the definition of the voltaic electrical cell? Is that clear?
So, an electrolytic cell, it's a non-spontaneous reaction. The difference between the cell potentials will be higher than zero. It's going to have lower energy reactants and higher energy products.
Yeah,
So for the second question, which type shows an increase in free energy? My answer was electrolytic cell. And for the one that has less difference between the cell potentials will be low in voltaic cell.
yeah, yeah. I got it. I remember. Yes, it should be less than zero. Yeah, I got it. And what about the increase in the energy, free energy? Can you tell me this one?
Electrolytic cell, because it shows it has a higher um what was it? I forgot again. difference between the cell potentials. It has a higher difference between cell potential.
Okay. So overall, we can see what? Which one should show the increase in the energy?
Electrolytic cell.
Yes, right. Because in electrolytic cell, you have to spend electricity. Electricity, and it means the lower energy reactance goes to the higher energy reactance, which means the energy is changing towards the positive direction. They are increasing. Is that clear? The first one is voltaic cell, and then the second one is chemical
Yes, electrolytic cell. I
electrolytic.
have been saying this since the beginning of the question.
Okay.
Okay,
So,
which statements are true? Correct any that are false. Uh,
so
in a voltaic cell, the anode is negative relative to the cathode. Yes, it's true.
anode is negative. This one is anode. As our example, this is zinc minus because it loses electrons, and the copper is more likely than electrons, it means the plus cathode. So anode negative should be, yeah.
Oxidation occurs at the anode of a voltaic or electrolytic cell. Oxidation occurs. True. True.
Yes.
Electrons flow into the cathode of an electrolytic cell. No. Yes.
Yes,
Wait.
they should be flow. As you can see, zinc loses
Yeah, the
electrons,
flow will happen from the anode to the cathode. So it's going to come to the cathode.
in the anode process, oxidation occurs. What is the definition of the oxidation? Losing electrons or
Loss
gaining
of
electrons?
electrons. Loss.
Losing electrons. It means they are not receiving the electrons. The anode,
Yeah.
the cathode,
So the cathode is receiving electrons and the C is true.
yes, this one is true. In the next
Um,
one,
in a voltaic cell, the surroundings do work on the system. False. The
false.
system does work on the surrounding.
Yes, right. Next one,
Um, a metal that plates out an electrolytic cell appears on the cathode. I don't understand what plate is. That plates out.
electroplating. Do you know what electroplating is? Electroplating. Electroplating. You stack two electrodes each other, one solution, and there are some metal ions exist on this, and here
The
also the
core.
metal ions exist. Whenever you conduct electrical energy to these solutions, these ions stack to this, attached to this electrode, and the mass of these electrodes becomes fatter, and which means the electroplating is occurring.
True.
So can we use this electrode out of the cell? For example, here, out of the solution. This question is this.
Is it true?
It is not true. Why? Because if you take out
It's
this,
not asking that. It's asking a metal that plates out of an electrolytic cell appears on the cathode. It's saying, does this plating take place at the cathode?
appears on the cathode.
Yes.
Here,
Yes,
you should,
I think
you should concentrate on this section. Out of the electric.
it's not saying out of the electric cell. It's saying a metal that plates out, not out, like not that out. Plates out is one word, like
What
has a
about the
one
off?
meaning.
What about the off? Where did it
Like,
come
oh,
from?
wait 1 minute.
Can we use the plate without out? You know, electroplating. This is not a phrase. Plate out, it's not the proper phrase.
I think it's saying a metal that
No, it
the
shouldn't be.
metal which is being plated out taking place in the electrolytic cell appears on the cathode. Did you understand what I said?
So it appears on the cathode.
The plating out process happening in the electrolytic cell appears on the cathode.
Okay.
So I think
The
it's true.
cathode.
Yes.
So what about the anode? What's the function of the anode?
Is that still the metal?
So can this electrode absorb the ions into it?
The voltaic cell.
Is that possible?
What did you say?
So can we electroplate the anode? What is your idea?
Anode is the one releasing the electron of the metal.
So the function of the anode is to losing the electrons, right?
Yes.
If they lose electrons, it means they have to they have to transfer the electrons here. And the function of the cathode is
Receiving electrons, gaining electrons.
receiving electrons. Yeah, it means they are they're gonna receive the reduced ions from the solution. Right? It means only the cathode. Yeah. Okay. So you know here I found the two meaning from these 2 meaning from this sentence by paying attention to the out of.
It's not saying goes out. It's saying plates out.
Okay, so so I'm not sure 100% because this sentence also is logical, you know? If you take this electrode out of the cell, and can you electroplate that cell out of the electrical cell? Is that also can be question? If this sentence means that, the
Then the answer will be no.
answer should be wrong because it should be in the solution because the
Okay.
electrons exist on the solution, not the surrounding. So the next one, cell electrolyte provides a solution of mobile electrons.
What is mobile?
Do you know what mobile phone is? You can
Yes.
you can carry that mobile into any place. It means
Movable?
movable. Transfer electrons.
Cell electrolyte provides a solution of. Want it be ions?
Electrical. So cell electrolyte provides a solution of the mobile electrons.
Want it be ions?
They form the ions, yes. But what about the electrons? No.
I think it's false. I'm not sure, but I think it's false.
In the solution, we have only the, for example, anions and cations. We don't have the electron itself on this solution, which means electrolytes cannot provide a solution of the mobile electrons. Electricity, can provide the mobile electrons.
So what's your answer?
So, so the second hesitating fact is this. So, these anions gives electrons to the anode, and these electrons are movable, and they move towards this direction, goes to the cathode. These ions are being provided by the anodes, which are the part of the electrolyte. Did you get it?
Okay.
So what's the question is asking us? Mobile electrons solution provides the electrolyte. A solution of the mobile electrons. No. So the conclusion is this. The solution is this one. Electrons are exist in the water molecules, but here we don't have any individual electrons which are exist in the solution. That's why this should be wrong. Whenever we conduct energy, the anions attach to the anode and they can share these ions into it. But this but these electrons are not coming from the solution. They are coming from the anions. Is that clear?
Mm-hmm.
You know the solution means the mixture of two things, the water molecules and the electrolyte. But the solution of mobile electrons are not exist because it means the electrons like this electrons differ diffuse into this solution, which means the solution of the mobile electrons. Mobile electrons exist in the metals. For example, iron and also aluminum. They are mobile electrons.
Okay.
So, but in the solution, we don't have any individual electrons. These individual electrons only forms when the redox reaction occurs. Okay? You should understand in this way. Do you have any question?
No.
If you don't have, so continue to solve to your problem solving and send me as much as you as many problem as you can. I will check them and I will give feedback. And I hope this week we will begin our new topic. Okay.